The methods differ by elements that you are going to construct. Okay, generally speaking, construction follows according to the element, according to the members you are designing, according to the location. They are all different methods. But in this class, I will explain about how the members are designed, how the building design is varying between one level to another, and so on. Right? We don't do much on the design part. Always remember, sometimes students ask, what is about the design part? Okay, design part we don't touch upon. Design is totally different from the construction. Okay, right. What are the elements that a building has? When you see the building, what are the elements you can guess at this point of time before you learn this method? And the components, take it to be building components. What are the elements that you can see, one can see in the building?
Column.
Column. Next, good. Next point.
Beam.
Beam.
Walls.
Walls. Good.
Concrete
Anything
slab.
else? Slab. Very good. Next.
Roof.
Roof. Slab. Okay. Roof. Roof. Yes. That's all. You have said the major things, major things, major elements.
Ceiling.
It's not a major thing. Ceiling is one of the additional work, right? I'm talking major elements. Ceiling is the part of the structure. It is not forming an element at all, or part or component of the building at all, right? In your task, for example, you're preparing the Gantt chart for the project schedule, you should put it as a roof or slab construction, not ceiling construction, unless it is a plastering, right? If it is a job of plastering, then you need to do part by part, section by section. Okay, so I repeat, this building construction follows how you, anytime you cannot see the slide, you please tell me, because my gadget is not working right now. It's not showing anything, that's why I got lost sometimes. Anytime you cannot see the slide, please tell me. Right. Mainly they are of slabs, beams, columns and walls, right? The slabs can be floor slab. We will see in different things. Right now I give you preamble of what are these things. Roof slab, floor slab, mezzanine floor slab, what else? Underground, anywhere. And then wherever the continuous width and breadth is higher, then it is called slabs. Beams. Beams may be of cross-section circular, rectangular, triangular. Normally the cross-section is the dimensions of the cross-section, right? Dimensions of the cross-section. Remember what I mean. Length mean width and width of the beam, and the depth of the beam will be lesser than the length. Width and depth of the beam will be lesser than the length. Lengthwise it will be extending, provided the cross section is smaller than the length by dimension. It may be of circular, rectangular, triangular, hexagonal, any type of, any shape of beam can be constructed according to the architecture's design for your house or the project that you are doing. Columns of the vertical members. Again, similar. Sometimes you may get confused between designer when you're doing your RCC design later on. You may get confused between these two members. Column and beam look like same. At the building site also, all, if it is a precast, also the suppliers loaded all your materials for beams and columns. Sometimes you get confused between beams and columns. So you should really differentiate between these two. They look similar, but function-wise they are different, right? Vertical mostly vertical members are called. In high direction, in height, above the ground, they have. Yes. Any question? So vertical members are, if you put the beam in a vertical direction, you will see that as a column. I will show in pictures so that you are clear how they are different. They look like similar when it is laid or stuck at the site. When the functionality wise, it is different. Some construction they go for uniform size of beams and columns. Sometimes uniform column, beam and column, and then they construct. Maybe the loading is good enough to be carried by this uniform cross section of beams and columns. And then walls. Walls are the continuous member again, constructed between columns, to provide the occupation in a closed environment. Between columns, between sometimes it is between beams, right? If it is from floor to floor, and so on. Let's see one by one. Before I go into this one, all of you answer me whether you go through this publication or not. It's so mandatory. Answer me. Did you go through this publication or not?
Please go through or go to.
Go through means just read like in your magazine.
No, I just go to the website, the link.
Contents, right? Contents page, just flip through some pages, isn't it? Anybody else? Thank you. Anybody else who have gone through, just flip through the pages or read the contents, interested to read? It is very important for construction engineers, right? UBL, the dates I told you to go through, I've also posted it under further readings under in CN. I have already posted in your LMS CN. I already posted these two publications. Actually, those two publications, and actually this one is not important. You can follow this and this. I posted this and this. Two are important. Sometimes they may ask you. I don't cover this in the exam, but I cover this portion in the exam. So you have to be thorough of what is given there, right? Some important points, key points you should read and remember. This one, can I ask one moment? All of you go to LMS. Oh, you cannot switch over. Okay, I open it. It's a Bible of construction engineers. When you go to site, right, in your co-op, in your training, or in your job place, if you are going for, working as a construction engineer, field engineer, you should know what is UBBL. All the regulations, guideline, rules, law, policy, standards, specifications are all there in UBBL. You can flick through the pages and check what are the things. Now I request John 2:9 to read this page. I open the page. I request him to read. This is the thing. Can you all see the one I shared? Can you see the book?
You can see the slide.
Oh, you can see the slide only. One moment. I will share this too. I don't know why it's functioning in a different way. I hate this giving me too many things to do at the same time. One moment. I share this PDF. What happened? No PDF. PDF is there. Okay. Desktop. This is so confusing. Wait, share one, lost another one. Okay, go by this publication. Reading material. Wow, I can see now. UBL. Can you read through this one? Can you see? Can you read through this one? Wait, page number. Take the page number also. See, it has sections like starting from preliminary, right? Preliminary, submission of plan for proposal, approval, space, light and ventilation, temporary works in connection with building operators, structural requirements, construction requirements, fire requirements.
Miss,
Yeah?
we can't see it.
Oh, I didn't share. What's happening, Lord? This gentleman not opening this file. It open from this area. How come it's missing here? Give me a minute, I'll open it. Modi's tongue is more important, running like anything. Okay, I opened the file already. 1984 publication, let me share. Apparently. What's happening here? Something happened to my desktop. You can see, no. You can see now. Oh, thank God. I need to understand more this thing. See here, this is actually the original publication. Original publication of UBL started from drainage system. See, street drainage and building. There was a flood occurring in the community late 19th century, right? And then beginning of 20th century. So they started building some. They found it is important because after the flood there is a disease spread. After the disease spread, you can see many deaths, fatal, right? So then they understood the importance of having proper building, proper drainage, proper disposal. So the very first one, the act that come into picture is Street Drainage and Building Act. From there they started imposing law, policy, developing law, policy, strategies, reporting requirements, everything for buildings together. So infrastructure, drainage forms the infrastructure, the building forms the main structure. So they started with the infrastructure, then it is also applied to, they develop into buildings, main structure of the building as UBL in 1984. So this publication has all the preliminary things. I will do one by one, and let me read the title only. Submission of plans for approval, space, light and ventilation. So the first question, the contractor or the field engineer or your supervisor will ask at the site is whether you know UBBL or not. Sometimes they call this as UBL or UBBL, right? Uniform Building Bylaws, UBBL. Don't forget, tell them yes, I have gone through, I know. You can adapt them strictly in your designs, in your work. Temporary works in connection with building operations. Structural requirements, all types of structures. You're coming back to this one later. And then construction requirements. Construction requirements. All the types of how the site should be maintained during construction. And then after construction, what are the structures to be maintained? Fire requirement. Although you have OSHA requirements, fire requirements also one of the things that is coming together with UBBL. Fire alarms, fire detection, fire extinguishment, firefighting access. One of the provision which has to be constructed inbuilt together with the electrical line, all the infrastructure things, electrical line, drainage lines, and maybe gas line if it is a gas supply. The water line may be two types of line, cold water and hot water. In UK, if you are designing, you have to do two types, hot water and cold water lines. They should not mix. Or somehow you manage to heat on line according to the outlet, operated by the outlet, and then miscellaneous. So some more laws are building to which part, 7 and 8 and so on. You don't have to go through the entire thing, but let's go back to this one, the building components. May I request John to read this one? Where is this timber flooring? I want to start with the. Where is this one? Walls are there. Maybe here. Okay. John, can you read for me by law 55, dead load and superimposed load? Can you go there? You start from 54. General requirements of loading and dead load and imposed load. Can you do it? I've given the assignment to John. Can you read aloud? Everyone listen. There is no page.
Yes.
Please read for me general requirements of loading by law 54. Oh, wait, I open for you. Don't worry. 54. By law 54. General requirements of loading. Like this, you can refer through. Come on, answer. Read for everybody. General requirements of loading. John. Start reading. John is there. You can switch on your camera. I put up myself. Can you switch on your camera and read? John 2 is there. If not, I give the chance to Mohammed Zain Isa. Mohammed Zain Isa online?
Yes, miss.
Please read the page that is shown there. I think it's still there. Can you read? Can you read?
Okay. Yes. So 54, right?
Yeah, read 54. Law 54 says, by law 54 says general requirements of loading.
So number 1 is in determining the purposes of these bylaws.
Yeah, read whatever it is there. Don't use your own words.
Okay, miss.
Sir.
In determining for the purposes of these bylaws, the loads to which any building will be subjected, the dead and imposed loads and wind loads shall be calculated in accordance with this part. Provided that in the case where A, an actual imposed load to which a building will be subjected will exceed the imposed load calculated in accordance with this part, such load shall be substituted for the load so calculated, and part B, plant machinery or equipment will produce exceptional dynamic effects, there shall be substituted for the imposed load. Calculated in accordance with this part, such great amount which would, as a static load, produce stresses of a magnitude and kind approximating to that inducing dynamically. Number 2, in determining for the purposes of this part the loads to which a building will be subjected. A. Dead loads shall be calculated in accordance with PSCP 3 Chapter 5 Part 1 or as provided here in this part or provided hereinafter in this part. B. Imposed loads shall be calculated in accordance with PSCP 3 Chapter 5 Part 1 or as provided hereinafter in this part, provided that if any actual imposed load will exceed or is likely to exceed the load so calculated, that actual load shall be substituted for the load so calculated. And C. Wind load shall be calculated in accordance with PSCP 3 Chapter 5 Part 2, provided that A. In no case shall the factor S3 be taken as less than 1, and B. If a building falls outside the range of those for which that codes give them forces and pressure coefficients value shall be used which are appropriate in relation to that building, having regard to this construction, size, proportion, shape, profile, and surface characteristics.
Okay, thank you. Thank you, Lisa. Right. This section says all about the types of loading, major types of loading, and then followed by individual types. It is explained, right? Number one, you will be learning during your RCC design. And if you go to the site also, there will be having a typical design at site. Your engineers would have done. You can follow them and you can learn the method. If wherever there is a problem, there is like the extra size or resizing, wherever you come into problem, you can come and refer to this laws, what the law says. Even this can be for construction, adapting, following. If there is any mistake also, if there is any issue happen, anybody has made mistake, like a contractor made mistake, architecture made mistake, you can use this law to sue them so that it is properly handled, right? Okay. With this, like this, you please read through UBBL. I'm not going to explain much on this because you need to know what is the design aspect of each and everything. Then only you will know what is S3 type of loading, S2 type of loading, and to be clear. But this is for your reference that you should go through each and every item when you are constructing respective elements. Adapt them and follow the guideline given as in UBBL. Right, then and there we will refer through that. Now coming to our class about there's other one, right? This one. The second part of this one, I also have to teach you. Maybe after the slides I will do it. Let me go through the members so that you are having idea about what members they are doing. Then you can understand about these things. Right. UBBL, I will go through this one at the end of the slide. Circular additions. Okay, whenever there is a change, whenever there is a change, there is a amendment in the law, policy, a requirement to make it stringent or liberal or additional points, they will issue as a circular. So a circular will be appendix to this one, this publication. This will be a publication for this, and this is circulated by LAM Architecture, Lembaga Architecture. I forgot the full form. Lembaga Architecture Malaysia. So they have issued the circular to follow for construction sites, how to report an accident, how to report an incident, maybe caused by during construction or after construction. This is so important, and you will really appreciate learning these things. I will do it at the end of the session. Load distribution. Technically, now technically I brought this picture for you to understand. These things, it is actually disjointed to show how the load distribution is happening, right? This assembly is not a real structure in land, okay? All these things should be attached. To show the distribution of loading only, they are detached from one part to another. Start from here. If you see the load distribution, all of you know the members, slab, beam, column, all you know, right? This is slab, this is beam, this is all the tie beam. We call, if it is running all through, they call this as a tie beam, holding this whole slab. And then column, footing, right? If it is above ground, there is a small structure which is supporting column, is called a footing, and then followed by foundation and so on. Okay, foundation can be a pile or a shallow foundation or any type of shallow foundation below, right? If you see the distribution of loading, all this, the explanation about the slab distribution depends on again design, one way, two way, and then whether it is a more compression or tension taking. All these things you will study in your RCC. I don't want to confuse here. Let's understand the pathway only. The route it is distributed to the ground. All of you know that these structures of bearing the load have to be designed properly to support the building. All types of load. Just now you studied 3 types of load: dead load, imposed load, and wind load. Wind load is mandatory if the building is above 3 floors. Up to 3 floors, like residential building constructed in a compound, in your compound, or any building, bungalow type, not necessary that much. Generally speaking, 3 floors, you can still design without wind load. It's applicable. About 3 floors, like how much the height of each floor? Any idea? Rough idea about the height of each floor? Rough idea.
10 meters. 10 meters.
You
3 meters.
right, 3 meters correct. You check your room, just a guess like engineer, you should have a guess on seeing the length and breadth. You should have a guess 3 meter high normally. If you are sitting at home, house generally 3 meters. At 2.5, they go for mezzanine, right? And the lintel level will be 1 meter below lintel level. There is another beam supporting the structure. These are all you, when you go for construction site, you will know this part. I will explain one by one in these slides. Now, where we are, 3 meters. Three floors, when I say 9 meters, so up to nearly 9 meter less, you don't have to bother about wind load that much. But when it is rising above 3 meters, 3 floors, wind load comes into picture. You need to construct, you need to analyze the building for wind load before you go for construction. There are type 3, type 1, type 2, type 3, there are different combinations of loading. Later you will study about when you go for design, actual designing members, right? Start from here where we are. This is the slab. So all this, because it's continuous, the loading type will be distributed, not a point load. This is a point load, at least at one point only. Maybe a bureau here, almirah here, maybe a cabinet here, a point load. The cabinet is not, maybe this almirah is not spread all over, it's only here. And then a cabinet is only at this point, not all over. Then it's called point load. Distributor load means, say for example, this slab, self weight of the slab itself is a distributor load, is spread all over. And this load together with the imposed load and the self load will be coming or taken over by the beams. So the load distribution starts from slab to beam in this way, right? The member is continuous. So all through the points it is distributed. It is not a point. It is not acting at a point. And you can calculate the net load, but that comes under the design part. For now, try to understand how the distribution is taking place. So from the slab, it is distributed. We do not know what is the spacing, and don't ask me what is the spacing. In analysis, you may get it in plotted, but truly speaking, the spacing of this one depends on, again, the loading and all other design part, right? I mean, design of your members. It may be reinforced or just a concrete. Okay, after this load comes to beam, from the beam to the column. See, again the beam is like a point load, it's not a distributor load. At this point it is it is supported, so it's a point load, and then this load is again distributed to the footing to the foundation. Then the foundation should resist the entire loading. The black man, this black man is a black cords, like black cords for your prime ministers and president. They are black cords supporting the whole thing. Transfer the load to the ground or resist the load coming in, so that the structure is withstanding the load, not failing or collapsing. If the resistance is not equal or more, then the structure automatically fail. Okay. Any question in this case? If no question, I move on to next.
Sorry, ma'am.
Yes.
What's the difference between the linear loads and the surface loads?
Where is it here? There is no variation. You see the arrow? All are same, equal value. 5 ton, 5 ton, 5 ton, 5 ton, 5 ton, like this. Linear loads. But here there may be variation. The surface loads may be varying, depending on the occupants, depending on the moment, right? It may be varying. Imposed load, we call this as imposed load. The other name for this one is the imposed load. Imposed load will be some people standing here, using here. Sometimes the furniture is moved. It may or may not present. And the quantity of loading will be keep changing. But here there is no change. Constant.
Okay.
It's a constant load. Constant load. So when you calculate, maybe they have a platform here on top. There is a platform going to come. That's why they are putting another. These are all imposed load. These are all imposed load. Selectively they are given. This may be linear load. This may be surface load. This may be point load. In addition to that, the distributed load caused by this slab. Okay. The terms are interchangeably used, but you can call this as whether it's a varying type of load, in the varying itself, whether it is a uniformly varying or varying type, that is also there. Okay, so all these types of varying non-linear types will come under surface load. The linear will be constant or not changing. So you can just sum up and do it. Here, if there is variation in the load, you need to analyze what is the variation, whether this portion is high, or this portion is high, or this portion is high. Okay, that is called analysis. In the analysis, you will know what are the vulnerable points, why the structure tend to fail, then support with the design, required reinforcement or the materials. Okay. Any other question? Okay. If not, so try to understand these members and how the loading takes place, so that you will have an idea about designing the member. For example, the main concept of designing, knowing this loading is, when you design this one, you need to include all this type of loading. When you include this one, when you design this one, you need to include all this weight, all the load coming in. When you design this one, you need to include all this weight that is coming over, something like this. So plan properly. In your design, you should know what are the things to be included under the types of loading. That is most important. Next one is different cross section. Below. Just structure, concrete structure. Okay, the members, it may be column or beam. I put it common, that's why I brought it very first. You should know, otherwise you cannot imagine. I already told you beams and columns are looking similar, right? In construction, in functionality, they are varying. So you see the picture with the columns here, right? Circular column, square column, maybe rectangular. This one, this side seems to be lesser. Rectangular, square, circular, different types of columns. And the cross section can be H or I. It can also be called I, a channel, okay, a channel type, a square type, angle type, T type. So based on the cross section, it may be varying. These are all steel columns. Steel columns are the steel members. So when you compare the stiffness, please make note of this. These things you have to remember, because you are not going to test it right now. Just better remember which is of highest strong strength, which has highest strength, whether H or angle or channel or T, which is more higher, which is having higher stiffness than the other one. So you can compare. I repeat once again. Maybe it's depending on the material. I see here nicely framed such a way that the load can be nicely distributed, and this one is the channel, right? Although this area is unable to distribute, it has to distribute through this area only. And this one functionality is very good, but stiffness is lost. You need to imagine why. Because of this thing, because of the this hollow portion, major hollow portion. And then angle is also very slender here. Only this much portion can be used to support. And only this much portion can be used to support, but the transferring load at this point is very low. That's why it is put very low, at very low stiffness. Okay. The technical meaning of stiffness, calculation of stiffness, there is a method itself, stiffness matrix method. You will learn in analysis module. Any question here? Okay. You have code books for this thing. You have code books, steel code book published by every country. They have their own. Indian, China use Indian codes, later use British codes. When you do the project, they have to compare the values. One time, but there was a student who was conducted the project on. You see, American system. Everybody listen. There's a question for you. Maybe you can bring the answer next class. American system, they use more steel. No, the code book. Maybe you don't have knowledge right now, but better have an idea about how this is working. There are American codes, British codes, different countries. Most commonly used codes in your structural design software, analysis software, British codes and American codes. But there are some variations. One code is using more steel, another code is using more concrete. For designing a member, they recommend more of concrete, and the other one may be recommending more of steel. You should be able to know the differentiation, right? Which code book for designing a particular member for taking over a particular load, which code book is effective enough, and which specifications is giving you the affordable budget, under the budget, and the quality is not compromising. These things you should have an idea, knowledge on this. There was a student, master student, he did a comparison between these two codes, come out with interesting results, interesting answers on these types of codes, using different types of codes as a civil engineer or construction engineer at site. Okay, you also prune through all this information. Just have a read, no need to do too much reading. Anyway, you're going to use these codes in your design later on, but have an idea about which one is feasible, which one will be suitable for which type of construction. That idea should be there. They are different, varying. I will give you the answer next class. Better I read through all the findings by the student, master student. It's good for your knowledge. Okay, where the steel is used more, where the concrete is used more, which is affordable. There is a pros and cons. Okay, and then concrete structures. Types of structures. Coming to type of structures, by type of structure, type of construction will be varying. Here you see different shapes. Different shapes. Okay, I noticed this point. You can clarify me. In Middle East, the construction building and the building and all, the color is different. Brick color is different, soil color is different. You know why? Compared to Asia, like a building you see constructed in India, China, Indonesia, compare the building here in Asian sites to the Middle East sites. Saudi Arabia, Dubai, Saudi Arabia, Dubai. I traveled these places only. I found a difference in color of the building. Bahrain. Tell me, what's the difference? Because of the
Temperature.
what temperature? Now there is an important element, material. You can tell me in terms of material. There is a difference in the. You understand my question? Do you understand my question?
Can you repeat it?
The color of the building before any color washing, like the after brickwork is done. After brickwork is done, okay, they do the plastering, right? Right? They do the plastering. The end product of the building before finishing, the color is different from Asian sites. Why? What material is making the difference? Did you notice this first of all?
Cement.
Cement color. Is it a cement? No. Okay, answer the other question. What type of soil most commonly found in Saudi Arabia? Take Saudi Arabia one case only. Maybe the student from Saudi Arabia can answer me. What type of soil most commonly found in Saudi Arabia? Like if you say Malaysia, we can say red soil, right? Red soil or silt, mixed with silt, sandy. What type of soil is found in? Common type of soil found in Saudi Arabia. Or sand. What color of the sand? What's the color of the sand? White or grey or red? Hello, are you there? No idea.
Is it
Okay.
white?
Is it white, bright white? I mean, normal, the grayish white or red. The answer me whether it's a grayish white or reddish white. The sand.
It is reddish white.
Reddish white, isn't it? Isn't it?
Yeah.
I think that makes the difference in the color of the plastering. And then the reason here is iron content will be more. If it is reddish type, iron content will be more. And there is, I mean, it is susceptible for temperature, it's susceptible for getting, what do you call the color, decoloration. Decoloration is very fast. You need a plastering quite often. Proper plastering, I mean, white color finishing, proper finishing often to hide this fading of this color. There are maintenance will be more with these types of materials. This is my understanding. If you have any other answers, you can bring it to me next class. Right. So you should know the variation and the properties of it, soil, properties of the material that you are using, so that you can handle them properly. You see here this building. Can you see this building? Can you see this building? It's maybe finished one. You cannot find out the difference. And this is another shape. This is another shape, right? All are concrete structure, but different shapes. They're using beams here, and then wall, continuous wall, and then there's a slab, a special type of slab, and then a special type of beam here, right? And then special type of column supporting this slab. Steel structures, you are seeing a steel structure, different type of steel structure. The shape may be like this, where just vertical. Okay, one moment. This is the scaffolding. Yeah, under construction. This one is a dome type. This one some kind of, what is this? It's also under construction. Maybe reinforcement, right? Reinforcements. This is finished one. So different type of steel structure, full of steel structure. The structure which is using full of steel, no concrete, it's called steel structure. Composite may be both steel and concrete. See these beams, for example, this bridge is constructed using, the beams are steel, but the piers are concrete. The piers are by concrete. Due to any idea? Any idea? Why they made out of this one concrete? Engineer, ex-engineer, or engineer A, he has designed such a way that this is steel and this is concrete. Anybody?
High compressive strength.
Why steel is not having high compressive strength compared to many? Can you not design the same compressive strength using steel?
Reduce cost.
Maybe agreeable. And then any other reason?
More practice and cheap.
Yeah, the cost
Heavy.
he has already told.
Higher load.
Huh?
Higher load.
Higher loading.
Load.
No, you didn't get into the point. See, the location is on the highway. Any other answer, please? See, this part is hidden already inside, right? So there is no problem of rusting due to rain or water. This is not in contact with water, right? So you can still use it as a steel. You can use the steel to support the required loading. And this part susceptible for water, right? I mean, contact with water. Whenever there's a flooding, or what if the drainage of this highway is poor, then there is a hike of water, spoiling the member, totally spoiling subsequently spoiling the structure above. So normally they don't go for steel structure to support a bridge, which is exposure to, which is susceptible for waterlogging or any type of heavy flooding. Sometimes then the water may be until this part. Sometimes it cannot dispose. If it cannot dispose, then they have to the water will be there for 1 to 3 days and then to slowly drain out. That case also, it is dangerous if you have a steel structure. Right. And then video. Let me check. I have posted all the videos at the last section. Let me check what is this. War drowns and the methods used for construction. Okay, when you are studying these methods of construction, number one is manual. Manual and the methods follow as even in UBL. You're following strictly. Human beings are utilized for handling the construction at the site. Nowadays, due to AI, right? AI development and IR4 developments, we need to follow these types of drone survey or machine-made structures. Machine is making the structure, machine is supervising the structure, machine is mixing your I always have this problem. Can you all see the video? Can you see the video?
Yes.
One moment. So machine is doing the operation of everything nowadays. Just a small sample of how this is. So like this, there are many more operations which can be handled by equipments. What are the supervision you have seen here? Are you hearing me? What kind of supervision are taken place by these drones? Supervising? Answer me.
Machineries,
What machineries?
excavation machineries.
No, in this video, particularly in this video, it's only grading, right? Leveling the surface. It's shown the leveling the surface, and what else? What else? So clearly, the level, you know. Transporting materials. What is it doing here? This part. This part. What is going on? It's here. It's hope that tech will help solve a global situation. Late. Okay, tell me what is going on here. What kind of operation is going on? Huh?
Inspecting site safety.
No, what?
They use a drone to check the site progress.
Yeah, operation. You can name the operations going on at the site that is being monitored by drones. You have to name the operations, construction work going on. That is why I'm asking what is.
Were they using cranes to place slabs above?
See here, this part they are mixing, right? They are mixing, loading the material. At this part, it's loading the material. It's loading the Here, right? Is collecting the cement, maybe the dumped of the cement and sand, it is collecting and put into the mixer. Maybe mixer is, the picture is not clear totally, but useful for mixing. So if there is any flaw in mixing, normally the contractor will try to cheat in the mixing. If it is 1:2, 2:4, they will try to cheat by the cement. They will put 1:4 is to double the ratio or triple the ratio. That kind of operation you can monitor being an engineer sitting at your room. See, they are collecting the cement and then putting into different portions, they have to mix it. So you can sit here and observe how the mixing is done, whether the proper proportion is maintained, and thus you can ensure for quality. If the proportion is not there, you are compromising the quality already. So messy site, that could be conveniently monitored, and number of operations taking place in the site can be monitored conveniently by using these drones. Okay, you can watch through many such videos for more understanding. Right, and let me go through this one. We need a quizzes at the end today, or we postpone? Shall we have quizzes at the end? 5 minutes?
Can.
Okay. I stop at 6:20 and then continue for this. We have 5 more minutes. A concrete slab is a common structural element of modern building. Every building. Why I say modern building? In olden days, they always have a hut. The roof will be always a hut type, draining water naturally in a triangular form, right? So far, they never use the slab. Once that generation grown, the developments coming in, we have the revolutions coming in, we have modern buildings with proper strong slabs which can resist any type of loading. And the reinforced concrete slab is the one of the most important component in the building. It is a structural element of modern buildings. Concrete slab is maybe using only the concrete mixes or mixed with reinforcement. If the slab is with the steel or any wire mesh is added, then it is called reinforced concrete slab. It's not a mere slab, reinforced slab. The reinforcement is, the meaning of reinforcement is steel. They're using steel bar or a mesh or fiber to the concrete slab to make it stronger than this one. Okay. And then slabs are supported on columns and beams, that you already know, right? We have just now seen how the loading is being distributed from slab to column, column to beam. RCC slabs whose thickness ranges from 10 to 50 centimeter. Yeah. Generally speaking, they will design for 10 to 15 centimeter. If it is more than that, right, there are slabs, if it is more than that, then you have to incur more columns in between, right? But generally speaking, it will go up to 10 to 50 centimeter. Can you imagine about a foot, 1.5 feet, maybe 1.5 feet maximum. RCC slab. In the class, I am the only one person taking all the aircon. That's why I am getting cold. Right, my remote is not working right now. Need to change the battery. Now we are RCC slab, whose thickness ranges from 10 to 50 centimeter. As I told you, the maximum depth that you can go in for is 50 centimeter, most common. Thin concrete slabs are also used for exterior paving purposes. Very thin, half of this size may be for just pavement, and then just a portico extension of a building, a shade, sunshade, any kind of coverage, temporary coverage. Not taking the load. If you say the size is less, you should not take any load. Reinforcement design. Slabs are classified with respect to, just now I told you, maybe with reinforcement, without reinforcement, right? So number one is a reinforcement design, construction, and shape design. So based on these three categories, you can classify them. How are they? Based on the reinforcement, one-way slab. One-way slab means, wait on the picture. Why they didn't give the. Okay, I can show from here. One-way slab means that there's a failure in the one way only, hence you need to provide reinforcement in one direction only. Two-way, failure on both direction. I will give you the failure profile in the next class because it's getting very cold. Let me go through the theory first. Next class I provide the profile for you. One way will be, I repeat once again, the failure will be in one direction. You know the slab has breadth and width, right? If the failure is in breadth direction, either breadth or width direction, then it's called one way. Two way, both directions it will tend to fail due to the loading coming in. Then you need to design as a two way. Meaning you need to provide the reinforcement on both direction. That is mandatory. Okay, I will explain with the diagrams. That will be easier for you to understand. These slabs could be cantilevered or simply supported. Okay, the two-way slabs. These slabs can be either cantilever. Cantilever also, the meaning is supported at one end only. Simply supported means supported on both ends but not fixed type. You just kept on it like your garden slab. You go to park, you are seeing a bench, right? You are sitting on the bench, right? They are all called simply supported. Okay, I stop here for your class. I will continue in the next class. Let's go to the